In this presentation, I will discuss my data-driven analysis of Netflix mobile app user reviews. The purpose of this project is to understand customer dissatisfaction from unstructured text data and build a predict model that I can help Netflix identify negative app experience. The business problem is that Netflix mobile app is one of the main ways users interact with the service. Even if Netflix has strong content, users may still become dissatisfied if the app experience is poor. For example, problems such as login failure, playback issues, payment complaints, subtitle problems, app updates, or loading errors can damage the user experience. Over the time, these issues may increase dissatisfaction and potentially contribute to customer churn. To translate this into a data-driven problem, I define this project as a supervised machine learning classification task. The main analytical question is, can we use mobile app review text to predict whether a user review signals dissatisfaction? The target variable in my analysis is called dissatisfied flag. I created it from the star rating. Reviews with 1 or 2 stars are labeled as dissatisfied. So the target equals 1. Reviews with 4 or 5 stars are labeled as satisfied, so the target equals 0. 3-star reviews are treated as neutral and removed from the binary classification model. This makes the text clear. The model predicts whether a review indicates a negative customer experience. The dataset comes from Hugging Face and contains the Netflix mobile app reviews. The original dataset had 5,000 reviews. I used the review test date rating language and the data and date fields. After filtering to English reviews, cleaning missing or duplicate text, and preparing the data, I had 1,772 usable reviews. Around 50% were negative. 42.8% were positive, and 7.2% were neutral. The strength of this dataset is that it contains real user-generated feedback. This makes it useful for identifying actual pinpoints in the app experience. However, there are also limitations. App reviews may overrepresent users with strong opinions, and the dataset does not include actual churn outcomes. So I treat negative reviews as dissatisfaction signals, not direct churn labels. For data cleaning and processing, I first standardized the columns and converted ratings into numeric format. Then I created the sentiment label and the targeted variable. For text pre-processing, I converted reviews to lowercase, removed punctuation and unnecessary symbols, removed stopped words, and applied lemmatization. I also created additionally features such as review legends, word count, exclamation count, and question count. In the exploratory NLP analysis, I found that negative reviews are usually longer than positive reviews. Negative reviews had an average length of about 136 characters and 25 words, while positive reviews had 60 characters and 11 words. This suggests that dissatisfied users tend to explain their problems in more detail, while satisfied users often leave short comments such as good or great apps. I also look at comments word and big rams in negative reviews. Frequent negative words include app, watch, account, money, update, subscription, issue, work, and device. Important biograms include worst app, doesn't work, customer care, new update, and worst money. These terms show that dissatisfaction is not only about content preference. Many complaints are related to app usability, account access, payment updates, and technical performance. To make the results more actionable, I grouped negative reviews into optional themes. The largest theme was content and subtitle availability, with 245 negative reviews, or about 27.7% of negative reviews. Payment subscription and price issues appear in 186 reviews, or 21%. App update and installation issues appeared in 177 reviews, or 20%. Playback buffering and loading problems appeared in 161 reviews, or 18.2%. Login and account accessible issues appeared on 99 reviews, or 11.2%. These issues are useful because they can connect to specific business teams. Content and subtitle companies can go to content operations and localization teams. Payment companies can go to billing and subscription teams. Playback problems can go to screening quality teams. Login issues can go to account and identify teams. For feature engineering, I transformed the clean the review text into numerical features using TF IDF. I use both on-grims and by-grims so the model could learn from single words like payment and phrases like doesn't work. I also included numeric features such as review engines, word count, exclamation account, and question account. After removing neutral reviews, the final model dataset had 1,645 reviews. I split the data into 1,316 training reviews and 329 text reviews. I compared three models: logistic regression, multi-numerical naive-Bayes, and linear SVM. I selected logistic regression as a main model because it performed well and is easier to interpret. This is important because Netflix would not only want a prediction, but also an explanation of what language partners are associated with dissatisfaction. On the test side, the select model achieved an accuracy of 87.2%, a balanced accuracy of 87.3%, and ROC AUC of 0.92. For the dissatisfied class, appreciation was 0.899, recall was 0.859, and the F1 score was 0.879. I paid special attention to recall for dissatisfied reviews because missing negative reviews means Netflix may fail to detect user pinpoints early. The confusion matrix also shows strong performance. The model correctly identified 152 dissatisfied reviews and 135 dissatisfied reviews. It means the 25 dissatisfied reviews and incorrectly flagged those 17 dissatisfied reviews are dissatisfied. From a business perspective, the 22 missatisfied reviews are the most important errors because they represent users whose problems were not detected. I also used five-fold cross-validation. Logistic regression achieved an average accuracy of about 85.3%, and average dissatisfied class F1 score of about 86.6%, and an average ROC of about 91.2%. This suggests that the model is reasonably stable and not just performing well on one random seed. For model interpretation, I examine words that strongly predict dissatisfaction. Important negative predictors include not, byte, phone, money, account, login, cannot, worst, uninstall, waste, and terrible. These words match the NLP themes, especially payment, account access, device problem, and poor app usability. Based on the analysis, I have 4 recommendations for Netflix. First, Netflix should use the model as an early warning system. New app reviews can be automatically scored, and reviews with a high dissatisfaction probability should be flagged for product or support teams. Second, Netflix should build a weekly app review dashboard. Instead of not only tracking average rating, the dashboard should track issue themes such as payment, login, playback, app updates, subtitle problems, crashes, and download issues. Third, each issue theme should have a clear optional owner. For example, payment issues should be assigned to building teams, login issues to account teams, and playback issues to streaming quality teams. Netflix can also escalation rules such as flagging a theme if it increases sharply after a new app release. Fourth, Netflix should evaluate product vibes using review data. After each app update, the company should compare the frequency of negative themes before and after release. For example, if an update is meant to fix playback problems, playback-related negative reviews should decrease afterward. In conclusion, the project shows how Netflix can turn unstructured mobile app reviews into a useful business intelligence tool. By clearly defining the target variable, applying NLP processing, building a classification model, and connecting review themes to operational actions, Netflix can detect dissatisfaction early, prioritize product fix more effectively, and monitor whether app improvements are actually working. Thank you.